Alright, so we're going to be going over Unit 8, Worksheet 4. Notice I crossed out a couple here, so let's give you a good idea of what you need to know for the quiz we're going to have coming up. So before we even get started, just keep in mind that there are a few things you need to pretty much have mastered by this point. First is naming and writing formulas. Number 1 says, well, this gives you the formulas of being very generous, but like if you look at number 5, it says copper 2 nitrate. If you don't know how to write copper 2 nitrate, you're in trouble from the start. So if you need to review naming or how to write formulas, there's videos up on my Edline. The other thing is grams to moles, moles to grams. This should really be second nature by now, but if you still kind of struggle, if you still mix them up, just Google grams to moles. You'll find videos for that. Alright, so we'll start with number 1. Calculate the number of moles of potassium chlorate that must decompose to produce potassium chloride and 1.8 moles of oxygen gas. So decomposition reaction. First thing we always do is write our formula. KClO3 yields KCl plus O2. Now we need to balance this out. So I have 3 oxygens and 2, so I could tell I'm going to need to double this just so I can get it even. So let me try this. 2 there, 2 here, and 3 there. Alright, so balance formula is done. 2 of those, 6 oxygens. Good. So we rewrite our coefficients. That shows our mole ratio. And if I have 1.8 moles of oxygen gas, how many moles of potassium chlorate must decompose? X, 2 over x equals 3 over 1.8. So we cross multiply, so it's going to be 3x equals 2 times 1.8, which is going to be 3.6. And therefore x is going to be 1.2. Let me just double check. Seems simple math, but you never know. 2 times 1.8. divided by 3. Right. So x is 1.2 moles of KClO3. And let me check my sig figs. Problem gave me 1.8, 2 sig figs. 2 sig figs. We're done. That's number 1. Alright. Number 2 we're skipping, so number 3. I have ethane reacts with oxygen gas, produces CO2 plus water vapor, so it's a combustion reaction. C2H6 plus O2 yields CO2 plus H2O. First thing we need to do is balance this out. So I always start with my hydrogens. So here's what I'm looking at. 6 hydrogens, so I would need a 3 here. But if I put a 3 there, I'm going to have an odd number of O's, which I can't do. So when in doubt, double it. Instead of a 3, I'm going to put a 6 here. And therefore I need a 2 there. 4 carbons, 4 carbons. And now as long as my O's are even, I'll be able to put a number here. So that's 8 oxygens plus 6, so that's 14 total oxygens. So I need a 7 there. So my mole ratio is 2, 7, 4, and 6. Alright, so the problem says what mass of oxygen is required to react with 2.20 moles of ethane? Oh, they already give us moles, which helps. So since they give us moles, we're just going to write this directly in here. 2.20 moles. Well, I can't just find grams out of this, but I can find moles. So I'm looking for oxygen gas here. That's my x. 2 over 2.0 equals 7 over x. Cross multiply, we get 2x equals 7 times 2.20. Calculator. 7 times 2.20 divided by 2. X equals 7.7. So it's 7.7 moles of O2. We're not looking for moles, we're looking for grams. 7.7 moles of O2 times, looking at my periodic table, this one I have memorized, but just so we're clear, oxygen is 15.999, but O2 is 2 oxygens, so it's going to be 31.999, but we'll just call it 32.00. So 7.7 moles of O2 times 32.00 grams per mole. Mole cancels mole. Times 32 equals 246.4. At this point I want to look back at sig figs, 3 sig figs, so I'll just call it 246. And my unit is grams of O2. There we go. Number 5. We're skipping number 4. Alright. In the copper silver nitrate lab, copper metal and silver nitrate solution reacted to produce silver metal and copper 2 nitrate. So single replacement. Alright. Copper metal plus silver nitrate react to produce copper 2 nitrate plus silver. Again, if you don't know why I wrote copper 2 nitrate like this, you're going to need to learn that. Balancing this equation now. 2 nitrates, 2 nitrates, 2 silvers, copper, copper, we're good. So my mole ratio is 1, 2, 1, and 2. Alright, so let's see what type of problem is. So it's a grams in, grams out, but also a percent yield problem. Because I need to calculate the theoretical yield in grams in order to find the percent yield. Is this also a limiting reactant problem? Limiting reactant problem as well. Alright, this will be fun. So I have 2.93 grams of copper. I need to convert that into moles. Let me do it on a separate slide. 2.93 grams of copper times 1 mole over 63.546 grams. Gram cancels gram. 2.93 over 63.546. 0.461 moles of copper. So let me go back and write that right in. 0.461. Okay, my silver nitrate. 1.41 grams of silver nitrate. AgNO3 times 1 mole over silver is 107.868 plus 1 nitrogen 14.007 plus 3 oxygens, which is 48. So it's 169.875 grams. Gram cancels gram. And we get 0.00830 moles of AgNO3. All right, 0.00830. All right, so now we need to figure out which of these is our limiting reactant. Now, the way you normally do this is you pick one of these and you say, how much am I going to get with each of these products? However, if it's as blatantly obvious as this one, you don't have to do that. Normally, I need twice as much silver nitrate, but you can see I have like 20 or even like 200 times less than that. So this is obviously my limiting reactant. Even if I had like 0.6 or 0.7 of this, it would still be my limiting reactant. So this is definitely going to be my limiting reactant. So let's see what the problem asks. So eventually we need the percent yield. Okay? So now we need to see what mass of silver this would have produced, not what mass of silver that would have produced. Okay? So we need to find our mole ratio here, and this is actually easy. 2 moles to 2 moles tells us it's a 1-to-1 mole ratio. So I'm just going to go ahead and copy this number right down here. If you don't follow what I did there, just set it up as we normally would, where this is what I have, this is what I'm trying to solve, my x, 2 over 0.00830 equals 2 over x. Well, cross multiply and divide, so multiply that by 2, divide by 2, you're going to get the same answer. So we're expecting this to produce 0.00830 moles of silver. So let's see how many grams that we're going to expect that to be. 00830 times 1 mole over 107.868. Oops, that's why I include my units. 107.868 grams per mole. Mole cancels mole. 0.00830 times 107.868 gives me 895 grams of silver. So that is my theoretical yield in the perfect world with no human error. This is exactly how much silver I would get. But in this problem, I only get my actual is 0.87. So to find my percent yield is going to be actual over theoretical. So 0.87 over 0.895 times 100% is going to equal 97.2%. And that's our final answer. All right, number 6. When hydrochloric acid is added to sodium hydroxide or sodium hydrogen carbonate, I might have to change this one, or I'll at least tell you guys what that is. It's going to be NaHCO3. Products are water, aqueous, sodium chloride, and carbonate. You know what? I'm cutting that one. If you're watching this, don't do number 6. Let's see. Number 7. Phosphorus and bromine react vigorously together to form phosphorus tribromide. Phosphorus plus bromine. Bromine is a Brinkelhoff. Form phosphorus tribromide. All right. 5.0 grams of phosphorus and 35 grams of bromine react. How many grams of PBr3 could be produced? Limiting reactant problem. Let's figure it out. So first we do is balance this. Now since I have 2 bromines and 3, I know I need to double this to get this in an even number. 2, 3, 2. So my mole ratio, I'm just going to write it again. 2, 3, 2. And I'm going to need to convert my numbers into moles. So 5.0 grams of phosphorus times 1 mole of phosphorus over 30.974 equals 0.161. I'll go an extra sig fig just to keep it precise. Moles of phosphorus. And for my bromine, since it's, remember it's bromine gas, or it might be bromine liquid, but either way, bromine's a Brinkelhoff. So we're going to get 35 grams of Br2 times 1 mole over, remember to double the molar mass of bromine because there's 2 of them, So 79.904 times 2, 159.808 grams. So 35 over this equals 0.219 moles of bromine. So let me write these on my previous slide. 0.161, 0.219. 0.161, 0.219. Alright, so this one, definitely leaning towards this being my limiting, but since I'm not 100% sure, let's just kind of crunch the numbers and make sure. So I need to see how much product I would make with each of these. So using P, for this it's going to be 2 over this equals 2 over x. Since it's the same thing, we can just copy the number back down. Alright, so we're going to get 0.161 moles of PBr3. Using Br2, it's going to be 3 over this equals 2 over x. 3x equals 2 times that, so times 2 divided by 3 equals 0.146 moles of PBr3. So I was right, this is a slightly lower yield. So this is going to be my limiting reagent. This is going to be my excess reagent. All right, the question though asks, how many grams of PBr3 could be produced? So this is the moles, you got to convert this to grams. So 0.146 moles PBr3 times 1 mole, no, again, same mistake. It's grams over 1 mole. Got to add this up. So P is 30.974 plus 3 times 79.904, 270.686, 0.146, 39.52 grams. Let's look back at our original problem for sig figs. So I'm given 5.0 and 35. So we're going to cut this off at 2 sig figs. So I got to turn this into 40 point grams. Because that 5 makes it round up. And I can't just write 40 because that'd be 1 sig fig. So 40 point grams of PBr3 phosphorus tribromide. That's your answer. Number 8. Zinc sulphide and oxygen gas react to form zinc oxide and silver dioxide. Okay, so the amount of zinc oxide, what is the mass of the excess reagent, and a complete Mica table. Alright, so we got a lot of work here. Let's get started. First thing, balance the equation. Zinc sulphide, ZNS, plus oxygen gas, form zinc oxide, plus sulfur dioxide. Okay, we need to balance this. So I have 3 oxygens, 2 oxygens. Okay, let's see here. Yep. Alright, so a 2 here. Let me just throw some numbers out. 2 there would give me 4 oxygens, which works. 2 zincs, and I need 2 sulfurs. Yeah, this will work, and then a 3 here. So 2 zincs, 2 sulfurs, 6 oxygen, 2, 4, 6 oxygen. So 2, 3, 2, 2. Alright. Let's hope our limiting reactant is zinc sulphide, because this will be really easy. Let's hope it's not oxygen. In fact, either way, we're going to have to do the math, so let's just get to it. So I'm given 46.5 grams of this and 13.3 grams of this, so I need to convert both into moles. 46.5 grams of zinc sulphide. and I have 13.3 grams of O2. Now O2 I've done so many times I just know it. It's 1 mole over 32.00 grams. And zinc sulfide is 1 mole over 65.39 plus 32.06. 97.45 grams. Gram cancels gram. Gram cancels gram. Alright, so 46.5 over answer equals 0.477 moles of zinc sulfide. And here we get 13.3 over 32 is going to be 0.416 moles of O2. So let me rewrite these numbers on the last slide. 477, 416. Four, 7, 4, 1, 6. All right. So I can tell what my limiting reactant is. Because I need more of this, and I have less of it already, I could tell it's going to be the O2. Okay. Let me just double check that, just so we're all clear. So let me pick this as the one I'm going to go for. So with zinc sulfide, I'm going to get a 2 to 2 or 1 to 1 mole ratio. So it's going to be the same number, 0.477 moles. And with O2, we're looking at 3 over 0.416 equals 2 over x. So 3x equals 2 times 0.416 divided by 3. 0.277. Okay, so I was correct. Oxygen is definitely my limiting reactant. Zinc sulfide is my excess reactant. All right, now we're going to complete the Mica table, and that's going to allow us to solve the rest of the problem. So I'm going to start by rewriting my formula. Zinc sulfide plus O2 yields zinc oxide plus sulfur dioxide. Let me rewrite my coefficients. 2, 3, 2, 2. 2, 3, 2, 2. Okay. The Mica table, M-I-C-A. This is my mole ratio. I'm just going to copy these down again. 2, 3, 2, 2. For I, that's initial. How much of everything do I have initially? So, we already solved a lot of this. 477, 416. And since this is initial, I have 0 of that and 0 of this. Since oxygen is my limiting reactant, I'm going to lose all of this. Minus 0.416. Okay? So after, we're going to have 0 here. We've already figured out how much of this I'm going to get. With oxygen, I'm going to get 0.277. Plus 0.277 gives me 0.277. This is actually going to be fairly easy now. Hint, look for mole ratios when you see them. What I mean by that is this. I know that I'm going to produce 0.277 moles of zinc oxide. So if I produce this many moles of this, notice the mole ratio here, 2 to 2. I'm going to produce an equal number of moles of this, plus 0.277, 0.277. Remember, this is just addition here, 0 plus, 0 plus. So this is correct. Now, how many moles of zinc sulfide am I going to actually use up? Well, mole ratios. Notice the 2 here matches the 2 here. So it's going to use this amount. So I'm going to say minus 0.277. So this minus that, pretty clean number, not negative, 0.200. And these are now, my Mica table is complete. So I'm going to completely run out of oxygen. I'm going to have almost half of my zinc sulfide left over. I'm going to get this number of moles of these. Okay, but the problem doesn't ask for that. It says, what is the mass of the excess reagent? So the excess reagent is this. So I have 0.200 moles left over. 0.200 moles of zinc sulfide times the molar mass of zinc sulfide, which is 65.39 plus 32.06. So it's going to be 97.45 grams per mole. It says 49. I'm going to double check sig figs. 3 sig figs from the problem. 19.5 grams of zinc sulfide. Done. So that's worksheet 4. Okay, quiz, you can expect a little bit of all of this.